Chapter 5, Problem Solving. I like to think of it as the process of doing mathematics. Anytime we are doing mathematics, we're actually using some form of problem solving. They go hand in hand. So, what is problem solving? According to NCTM, problem solving is a major means of developing mathematical knowledge. It's at the foundation of what we do in all mathematics, especially in elementary school. Interesting enough, in the world of math, there's actually a lot of arguments about what is a problem and what does problem solving mean. They argue the definition all the time. For our purposes, we're going to define problem as a situation in which somebody wants to know something and does not immediately know the answer. So basically, we're presenting a situation to children and the answer is not immediately known, or the strategy to solve the problem may not be immediately known either. So, NCTM has recommendations on how we should be teaching mathematics. They call these the process standards. The 5 ideas listed here are the process standards. In the new Common Core, these process standards relate to the mathematical practices. As you can see, the big ideas from NCTM are problem solving, reasoning and proof, communications, connections, and representations. I'll show how these 5 big ideas also tie into the mathematical practices in the new Common Core. I'm actually starting with reasoning and proof. So one thing about reasoning and proof is we want children to reason about mathematics. We should be asking children why. Why did you do that? Why do you think this way? Why do you think that way? One big idea about reasoning or proving our thinking is that it's not taught in a single lesson. It's something we need to continuously be asking our children and working on throughout the course of a year. One big idea I think sometimes teachers tend to shy away from is that you actually need to make mistakes to learn. You learn more from mistakes than you actually do from getting it correct all the time. There are actually thoughts in mathematics research that say we should actually teach from mistakes and not from correct answers. This idea of reasoning and proof ties into mathematical practices 2, 3, and 8. That's the reasoning abstractly and quantitatively standard. It's the constructing viable arguments and looking for repeated reasoning. The next big idea is communication. You've heard me talk about this before and you're going to hear me talk about it again. Children need to be communicating in the mathematics classroom. I like to say that some people consider math to be a foreign language. You either speak it fluently, you kind of speak it, or you don't really speak it at all. So when we think about this, children need to be hearing about mathematical thinking and topics, reading about mathematical thinking and topics, listening to descriptions of mathematical thinking, and writing about their mathematical thinking. We need to be tapping into every aspect of language and literacy within the context of mathematics. One big idea in the book, as well as from NCTM, is that communication of mathematical thinking is a process rather than an end product. It's not the pretty paper they wrote, but the process of thinking when they explain and they work through their writing that's more important to relate to the mathematical content than the actual final pretty product. The next thing NCTM recommends is we make connections. There are 3 major types of connections that they talk about. First is the idea of math to math. And what that means is there are subjects within mathematics that are related to each other. So when you teach perimeter and area, you're teaching geometry, but you're also teaching measurement concepts. Next is the idea of math to other subjects. Here's an example of math and art connections. We can also tie math and science and math and social studies very easily. Next is math to the real world. We should be trying to make as many connections to real-life application of mathematics as we can for children. Next is the idea of representation. So what NCTM talks about is there are multiple representations of ideas in mathematics. As I'm working my way around these big ideas, I'm going to talk about how they're connected. So as you can see, we have pictures, written symbols, spoken language, relevant situations, and manipulatives. So one thing when we think about a representation of mathematics, we can represent it in pictures, which is also related to manipulatives. But that idea of pictures also relates here to the relevant situations, aka problem solving. We can also relate our pictures to the spoken word. And lastly, we can see pictures to the written symbol. As you can start to see where I'm going to go with this, all of these have connections. So the written symbols can connect over here to manipulatives. They also connect to relevant situations and the spoken language as pictures. So as you can see, it makes not the prettiest star at the moment, but all of these are interconnected, and we need to try to use as many representations to show children different ways of thinking about mathematics. So NCTM recommends that there are certain factors for success in problem solving. One of the first things is we need to make sure the children actually understand some of the mathematics we're going to use in problem solving. There's no point in putting out problems with mathematics the children have never seen. Second, we need to engage children in problem solving, but not wait till they've mastered computational skills. And what I mean by that is you don't have to have all your facts known as fast as a snap or memorize before you can start problem solving. Actually, the action of problem solving will help some children solidify their fact knowledge. Next, we need to make sure that we draw on a variety of strategies for children and not just say, this problem, it can be solved this way only. Children and adults approach problems very differently. We'll talk about this in class quite a bit. Also, we know that children's problem-solving achievements are related to their developmental level. Now that you're spending time in classrooms, you can see that children are at different stages in terms of development. We need to make sure that we offer math problems that meet these different stages of development for children within our courses. And lastly, there's factors which can contribute to difficulties with problem solving. One is knowledge and beliefs, control, and sociocultural factors. Sometimes children just don't understand what we're talking about. It's not very culturally relevant for them to be manipulating food, for example. In the Native American cultures, they actually revere food, and the only purpose for food is eating. You would never use candy or apples as a manipulative in a math lesson. So that would impede problem solving for those children. One thing I suggest is that you become very aware of the cultures of the children that are in your classroom and what's accepted norms. It's important for you to consider when you're thinking about your problem solving lessons. So these are the big ideas. I didn't talk about problem solving a lot in this video because we're going to talk about it in class. But I wanted to address those ideas of reasoning, improved communication, connections, and representations. In the mathematical practices, we have reasoning improved standards. They talk about communicating, such as constructing viable arguments and critiquing others. Representations, that's modeling mathematics or using selecting the appropriate tools to model mathematics with. So the big idea behind this chapter is that in the process of doing math, which is problem solving, there's aspects that we need to consider in our instruction.